Determine the radius of convergence and the interval of convergence for the following power series. Today we have 3 examples. The sum from n equals 1 to infinity n factorial bracket 2x plus 1 bracket to the power n. Second example, from n equals 1 to infinity bracket x minus 4 bracket to the power n over n to the power n. And third example, the sum from n equals 1 to infinity x to the power 2n and minus 3 in bracket to the power n. Now solution. We are familiar with formula of power series. We have an bracket x minus c to the power n. And now we compare our formula with our example. First example. We can see basic difference. In this formula is 1x in this place. In our example, we have 2x in this place. And because of that, we must convert our example. I rewrite our example. And now I write n factorial 2 times bracket x plus 1 over 2 bracket and all to the power n. 2 is not inside in bracket. Now it's okay because in this bracket is 1x and in formula, in bracket, we have only 1x. Finally, we have example, the sum from n equals 1 to infinity and factorial times 2 to the power n, bracket x plus 1 over 2, bracket to the power n. Again, we compare this example and our formula, and now we can see an equals n factorial times 2 to the power n, and c is equal minus 1 over 2. Why minus 1 over 2? Because we have x plus 1 over 2 in this bracket. Formula in bracket we have x minus c. Minus c is 1 over 2. Because of that, c is minus 1 over 2. This sign is important. Now we recall two formulae of radius. Limit as n tends to infinity, absolute value an over an plus 1, and limit as n tends to infinity 1 over the nth root of absolute value of an. In this example, we use this formula. We need an plus 1. An plus 1 is n plus 1 factorial times 2 to the power n plus 1. N plus 1 factorial is n factorial times n plus 1. 2 to the power n plus 1 is 2 to the power n times 2. Now we need quotient an over an plus 1 absolute value, and we have absolute value n factorial times 2 to the power n over n factorial times n plus 1 in bracket times n 2 to the power n times 2 absolute value. We cancel n factorial 2 to the power n, and finally we have without absolute value because n is positive, and we have 1 over 2 bracket n plus 1. Now we calculate limit. We can see when we substitute infinity, we have 1 over infinity and we have 0. Special case, r equals 0. We remember our center of power series is negative 1 over 2, and we calculated radius is 0. Because of that, this power series is convergent only at one point, only when x equals minus 1 over 2. Only for one point. This is special case. Now we determine the radius and interval for the second example. We have the sum from n equals 1 to infinity, bracket x minus 4 bracket to the power n over n to the power n. And we recall formula of power series. This form is different from this form. Because of that, I convert this expression. We have now 1 over n to the power n times bracket x minus 4 bracket to the power n. Now we can compare this example with our formula. an equals 1 over n to the power n, and c equals 4 because minus 4 is minus c. Now we need a formula. We use formula limit as n tends to infinity 1 over the nth root of absolute value of an, and now I calculate the nth root of absolute value of an equals the nth root 1 over n to the power n absolute value. N to the power n is positive, absolute value is not necessary. And now, after simplifying, I obtain 1 over n. And now I substitute 1 over n to this formula. I have r equals limit as n tends to infinity 1 over n. Now I multiply by a reciprocal. I have limit n as n tends to infinity. It's infinity, it's obvious. And now I write number line for here, for example. And now our radius is infinity. 4 plus infinity is infinity. 4 minus infinity is infinity. We have interval minus infinity, infinity. This is special case 2. Because for all real numbers, our power series is convergent. Now, third example. From n equals 1 to infinity, x to the power 2n over minus 3 in bracket to the power n. And now convert this expression. We have 1 over minus 3 to the power n, x to the power 2n. But when we compare this formula and our example, we can see difference. We have x to the power n. In this place, x to the power 2n. Because of that, I convert. And I wrote x squared to the power n. It's better, but not good because we have only x in formula. In this example we have x squared. It's different. Because of that, in this example, we use substitution. X squared equals t. In this place, we replace x squared with t. And now we have new power series. 1 over minus 3 to the power n, t to the power n. Now we can compare our example and formula. We obtain an equals 1 over minus 3 to the power n and c equals 0. For this example with t, we calculate radius and interval. Now we calculate the nth root of absolute value of an. We substitute an. We have negative 3, but we have absolute value. The sign minus disappears, and we have the nth root of 1 over 3 to the n. Finally, we have 1 over 3. Now we calculate r equals limit as n tends to infinity 1 over the nth root of absolute value of an equals 1 over 1 over 3. We multiply by a reciprocal and finally we have 3. Now we draw number line. 0 here is, for example, and now 0 plus 3 equals 3 and 0 minus 3 equals minus 3. We have interval of convergence minus 3, 3, but this interval is for this example with t? No, for this example. We remember we must check the convergence at the endpoints -3 and 3. First, I check convergence for t equals +3. I replace t with 3 and obtain series, this series. After conversion, finally I obtain the sum from n equals 1 to infinity -1 to the power n. My n equals -1 in bracket to the power n, and now I use vanishing condition and I calculate limit as n tends to infinity -1 to the power n equals plus -1. And it's different from 0. It means for t equals 3, our series is divergent. Now we check for t equals -3. I replace t with -3 in this place, and I obtain the sum of 1. an equals 1. I use vanishing condition, limit an equals limit 1 equals 1, different from 0. Our series is not convergent. Finally, we have interval -3, 3. But this interval is for power series with t, not with x. Now I write x squared equals t because it was our substitution. X squared is less than 3 and greater than -3. This part inequality is true for all real numbers because x squared is greater than -3 always. It means we calculate only x squared is less than 3. It means x is less than the root of 3 and is greater than minus root of 3. Our interval is minus root of 3 and root of 3, and our radius for power series with x is the root of 3. It is our answer. The root of 3, not 3. 3. It was for power series with t.